Hi everybody, we're back and we are in Module 5 now. If you are new to this channel, we are going through Exploring Creation with Chemistry by Apologia Chemistry Curriculum. We're going to go through the whole book, high school level chemistry class. Join us if you would like to learn some chemistry this year. We're starting in 2021 and we're going to go all the way through spring of 2022. So today we are going to learn about finding the finding the compound formula using polyatomic ions. Polyatomic ions. First, let's start by learning what a polyatomic ion is. So a polyatomic ion is a compound that has covalent bonds in it. It has atoms that are sharing electrons and they're bonded together. But it's also an ion, which means it has more or less electrons, total electrons in the whole compound than it has protons. So the whole compound itself is charged. I'm going to show you why. We're going to look at a carbonate ion. And I'm going to draw you the Lewis dot structure for a carbonate ion. So carbonate has one carbon and three oxygens. Now, if you notice here, the carbon has an octet because it's sharing 4 different bonds. So it has 1, 2, 3, 4, 5, 6, 7, 8 outermost electrons. So it is satisfied. It has an octet. This oxygen over here also has an octet. 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. But these 2 oxygens only have 7 outermost electrons. They are 1 electron short, and there's not enough electrons in this compound to satisfy their octet. So what happens is this compound is looking for electrons, and in the environment it's in, it usually can find atoms that are willing to donate an electron, atoms that want to get rid of their electrons in order to be satisfied with an octet. So for example, it might find a potassium ion floating around that wants to get rid of one of its electrons, or a hydrogen atom that wants to get rid of one of its electrons. Somewhere it has stolen 2 electrons. I'm going to write them in a different color. So these are electrons that did not originate in either the oxygen or the carbon. They're stolen from someplace else. But that means that there's more electrons than there are protons in this whole compound together. So this whole compound together has a -2 charge. It's an ion. It has a -2 charge as a whole. And the formula for this is C oxygen 3 -2. It's an ion because it has stolen 2 electrons. Does that make sense? That is what a polyatomic ion is. It's a compound that has covalent bonds, but it also has a charge because it has either stolen or donated electrons. Okay, that's the definition of a polyatomic ion. A compound that has a charge. A compound that has a charge. That's an answer to your quiz this week. Okay, let's move on a little bit. Your book wants you to know how to put polyatomic ions together in another compound and figure out what the compound formula is for that chemical. Do you remember in Module 4, the last video I did, we were putting atoms together and we were figuring out how many atoms are in a compound. and it was determined by how many electrons they had to give or how many electrons they wanted. And sometimes it was 2 potassiums to every 1 oxygen. You know, we put them together in compounds and we figured out what the chemical formula was. We're going to do the same thing with polyatomic ions. Now, let's do how we did it in the last review class. Let's do one like that, but then I'm going to show you another method for figuring it out that's easier with polyatomic ions. So let's say we have this compound and it hasn't stolen any electrons yet, but we're going to bond it with, let's see, we're going to bond it with oxygen. No, calcium. We're going to bond it with calcium. So we have a calcium over here. And the calcium from the periodic table, we know it's in the second row. So we know it wants to give away 2 electrons. It has 2 electrons in its valence shell. And so it's going to react with calcium. And this is where it steals its 2 electrons. 1 here, 1 here. And so there was only 1 calcium and 1 carbonate ion in this whole reaction. So the whole chemical formula is calcium with no subscript because it's a 1-to-1 ratio, carbonate. Calcium carbonate. Calcium carbonate. You add the ate or the ite onto the name if you're talking about the compound. Calcium carbonate. In your book, it has a whole list of polyatomic ions and what their names are. And it even shows you what charges they have if they have their octet satisfied. So this is what we were doing last module. We were looking at the Lewis structures and then figuring out the formula from the Lewis structures. The problem with doing that with polyatomic ions is sometimes it's really hard to draw out the Lewis structures of polyatomic ions. It just gets complicated, and there's an easier way to figure out the chemical formula. So I'm going to show you that, okay? But I wanted you to do this so that you tied it back to the last module and you understand what we're doing. We're combining 2 entities. We're combining the ion and a single atom into one chemical formula and determining what that chemical formula is. How many of each partner do we have? Okay. Now we're going to do that again, but in a different way. And this way is called balancing charges. Balancing charges. These ones I'm going to do for you right now are the ones that are in your quiz. So you can follow along with me and do them in your quiz and get your quiz done. So on the On Your Own questions 5.1, this is where these come from. We are going to figure out the chemical formula for BA, where's BA? For barium nitrate. Barium nitrate. Here's the name of that. Barium nitrate. Barium, is that right? Yep, barium nitrate. Nitrate. Gotta be specific. Nitrate. Nitrate. Barium nitrate. So, when you want to figure out the chemical formula of this, you have to figure out what 2 ions you're dealing with. Barium. Barium is easy. It's a single element. It's on the periodic table. It has 2 electrons it's trying to get rid of. So its ion, when it has an octet, is +2. That's the barium. That's the barium ion. Now nitrate. The handy-dandy table on page 175 tells you what the ion is for nitrate. Your book says that you need to memorize these. You don't need to memorize these. You can always go back and look at the table and know what ion, what charge you're dealing with. So barium nitrate. Nitrate is a -1 ion. It tells you that. It's a -1 ion. Now, how do these fit together in a chemical formula? We can determine that by balancing the charges. So, this is a charge of a +2. This is a charge of a -1. In a whole compound, we want the whole charge to be neutral. If we combine these just as they are, we would have a net +2 charge because only one negative charge over here would balance out only one positive charge over here, and we'd be left with a positive charge because there's 2 over here. So what you do is you balance the charges. What if we had another nitrate? Now our net charge would be +2 over here and -2 over here. The charges balance so that the net compound is neutral. And we know that we need 2 nitrates to do that. So the whole formula is barium nitrate, but to tell it there's 2 of them, you put a bracket around it and put a 2. You're telling whoever you're writing this for that there are 2 nitrates. And what's the overall charge of this? It's neutral because the charges have balanced out. So this is the chemical formula for barium nitrate. Do you see why? We're balancing charges to figure out the chemical formula. That's the answer to question like 3 or something, I think, like that in your quiz. Okay, let's do the next one. I might not do the 3rd one for you. I might see if you can do that one on your own. Okay. Next one is sodium chlorate. Sodium chlorate. Sodium chlorate. What is the chemical formula for sodium chlorate? So we start by finding the ions. What are the ions that we're dealing with? Sodium is, where's sodium? Na. Over here. It's a +1 ion because it only has 1 electron in its outermost shell, so it gets rid of that 1 electron in its outermost shell, and it has a +1 charge. So we're dealing with a +1 charge over here. +1. Chlorate. In your table, table 5.1, it says chlorate is a -1 ion. It's a -1 ion. So, what's the chemical formula? How do we put these 2 together that the charge of the whole is neutral? Well, there's 1 positive and 1 negative over here. So the net is +1, -1. They already balance in a 1-to-1 ratio, don't they? So the formula is sodium chlorate 3, and that's all you have to do. You just put them together because the charge is already balanced. Because it just happens to be that way. Okay, let's do the last one. I said I might not, but I'm going to. Last one is, oh, I don't remember which one I put on your quiz. I'm just going to do one of these, and if it's not the one that's on your quiz, don't worry, because all 4 of them are right here on page 176. It gives you the formulas right here. So it's kind of cheating for me to tell you that, but there it is. We're going to do calcium hydroxide. Calcium hydroxide. So first thing we do is figure out what ions we're dealing with. Calcium. Calcium is in column 2. It has to get rid of 2 electrons to be an octet, so therefore it's a +1. I'm sorry, +2. +2 ion. Hydroxide is a -1. It's OH. It's a -1 ion. So how do we combine these so that the charge, the compound as a whole, is neutral? Well, right now the charges are +2 and only -1, so those don't balance, right? So what if we add another hydroxide? All of a sudden, we have +2 over here and -2 over here, because there's 2 of them, and they each have -1. So look, the charge is balanced. So what is the chemical formula? It's 1 of the calciums and 2 of the hydroxides. Now, to say that there's 2, you put it in a bracket, and you put 2. Calcium hydroxide. Yep. And that's it. That's what polyatomic ions are, and that's how you combine them into a formula, and that's how you figure out what the formula is. So that's a significant portion of Module 5. After this, we're going to be talking about the shapes of molecules, which I think is much more interesting than this, but this is a really good thing to know. And we're going to be talking about these kind of things for the rest of the class, and I want you to have a really good foundation on ions and how to combine them. So once again, if you have any questions, you can comment on this video and I will answer, or you can email me if you have my email address. Thank you for watching if you're new with us, and come back for our next video. Thanks. I'm Kirsten, by the way, and this is Immerse Science Classes. Bye.